this some kind of spare satellite? Unlike the actual moon, the one that lights up our sky and gets blamed for werewolf legends, a quasi-moon never actually loops around Earth. Instead, it travels around the sun, matching our pace almost perfectly, like a jogger running alongside you at nearly identical speed. Outer space might look peaceful, but it's anything but. The sun, our moon, Earth, other planets, and even the smallest debris are all pulling and tugging at one another constantly. Most asteroids simply can't maintain this fragile equilibrium for long. They either get knocked off course, dragged nearer to Earth, or hurled away into deep space. That's precisely why spotting even one or two of these rare companions counts as lucky. Most objects just can't sustain the balance. These rocks fall under a broader category known as co-orbitals, and astronomers actually sort them into several distinct classes depending on how they behave relative to Earth. Unlike our genuine moon, which has stuck by us since the beginning, these temporary visitors never stay permanently. Some linger for a handful of decades, others for hundreds of years before some outside gravitational pull yanks them away, kind of like a dog abandoning you the second it catches the smell of bacon next door. Another curious detail is their scale. Most of them are minuscule, roughly building-sized or even tinier. They're also so faint that they blend right into the starry background. Even so, they matter a great deal. By observing these objects, scientists gain insight into how small near-Earth bodies behave and how long Earth's gravity can hold on to them. Quasi-moons sit nearer to us than other asteroids sharing similar paths, making them more accessible targets. Someday, they could serve as convenient waypoints for future space missions. Earth has picked up a few of these hitchhikers before. One of the best known is 2016 HO3, often called Earth's steady companion. Measuring just around 300 feet across, it has kept stride with us for nearly 100 years, and researchers believe it could continue doing so for centuries to come. Now, what about the newest discovery? Scientists have named it 2025 PN7. As mentioned, it's already been traveling with us for 6 decades and is expected to remain for roughly 68 more. It stayed hidden for so long simply because of its minuscule size, only about 62 feet wide, roughly the length of a single bowling lane. That also settles the question of whether you'd be able to spot it yourself, even knowing exactly where to look. Its origin story remains murky. Researchers still haven't pinned down what it's actually made of. Right now, the only certainty is its flight path. Some quasi-moons are simply near-Earth asteroids that happen to settle into this ideal rhythm. Others may actually be fragments of our own moon. Take Kamo'oalewa, for example, another quasi-moon whose light reflection closely matches the lunar samples brought home during the Apollo missions. Because of that similarity, some scientists suspect it may be debris from an enormous, ancient collision. There's also 2024 PT5, a short-lived mini-moon from late last year. Analysis revealed its surface resembles lunar basalt, hinting that it too likely originated from the moon. So how exactly do these quasi-moons manage this cosmic balancing trick? Turns out, it's basically an optical trick of orbital mechanics. Keep in mind, PN7, like the rest of its kind, isn't genuinely circling Earth. From our vantage point, it appears to trace lazy loops near Earth's path, almost like random scribbles across space. Yet it never falls too far behind or races too far ahead. Scientists refer to this as a one-to-one resonance, meaning simply that it completes one trip around the Sun exactly when Earth does the same. Here's another question worth asking. If these fake moons orbit so close to us, why doesn't Earth's gravity just reel them in, especially since they're small and seemingly nearby? The truth is, even though they're technically classified as near-Earth objects, quasi-moons aren't actually all that close. Our real moon sits roughly 239,000 miles away. These companions, though, are circling the Sun millions of miles further out, far beyond the reach of Earth's gravitational grip. That gravitational reach exists within a zone called the Hill sphere, the region where Earth's pull outweighs the Sun's. Picture Earth's gravity as a bubble stretching about 1,000,000 miles wide. Anything trapped inside can get captured, the way our actual moon was. Step beyond that boundary, and the Sun's gravity takes command instead. This is exactly what happened with PT-5, which briefly became our official satellite for 2 months back in 2024. It slipped inside the Hill sphere, and Earth's gravity momentarily claimed it. That's the moment it earned the title mini-moon. But since it was so small and moving so fast, it eventually escaped that bubble again, and the Sun's gravity reclaimed it. There's yet another category of co-orbiter besides quasi-moons and mini-moons, known as horseshoe orbiters. These rocks don't wander far, but from Earth's perspective, they appear to surge ahead, slow down, fall behind, and then repeat the cycle endlessly. It's a bit like an unmarked police car tailing you through traffic, constantly switching lanes and doubling back so you never quite catch on. Trace their movement relative to Earth over time, and it forms a distinct horseshoe shape, which is exactly where the name comes from. And these co-orbiters are only part of the picture. Far ahead of us and far behind, there exist a few peculiar rocks called Trojans. Unlike quasi-moons that trail closely alongside Earth, Trojans occupy 2 specific pockets, one sitting 60 degrees ahead of us and one 60 degrees behind. Picture cycling with one friend riding far ahead and another trailing far behind, both matching your exact speed. That's essentially what Trojans do. Those particular locations are called Lagrange points, stable zones where the combined gravitational forces of Earth and the Sun cancel each other out perfectly. Once an object settles into one of these spots, it can remain there for millions of years without ever drifting off. Jupiter, for instance, hosts a huge number of these hangers-on, while Earth only claims a small handful. Then come the tadpole orbiters. Rather than staying fixed at a Lagrange point, they drift lazily around it in bean-shaped loops. And if all of this hasn't already stretched your brain enough, there are also jumping Trojans, the indecisive members of the family. These objects can't commit to one side, spending thousands of years camped in front of us before gradually migrating to trail behind us instead, then eventually swinging back again. Rare, bizarre, and honestly kind of amazing. So even though Earth only claims one true moon lighting up its sky, we're actually surrounded by an entire crew of sneaky cosmic tagalongs. Some loop endlessly, some trail behind, some tuck themselves into hidden corners of space. Now, let's circle back to what makes our actual moon so remarkable. It controls our tides, gradually slows Earth's spin, and even helps stabilize the tilt of our planet's axis. Without it, our days would run shorter, nights would grow darker, and seasonal shifts would turn far more unpredictable. The moon also functions like a massive shield, absorbing or redirecting space debris that might otherwise collide directly with Earth. And we can't overlook its cultural weight either, inspiring folklore, calendars, love ballads, and countless late-night walks filled with quiet longing. Fake moons simply can't rival that legacy. Still, they carry their own kind of significance. Every newly discovered quasi-moon deepens our understanding of how these small objects endure amid all this cosmic turbulence. Studying our surroundings, in a way, teaches us something about ourselves, too. They refine our detection methods and strengthen our scientific models. So while they'll never glow in our night sky, they quietly continue shaping how we understand our strange and fascinating cosmic backyard.
That wraps things up for today. If this satisfied your curiosity, hit like and pass it.